Hi, I wanted to take one little step further into unit conversions because there are a couple of problems out there that can be a little confusing if you're not quite sure what to do. For example, a lot of times when given a density, there could be some value in looking at converting a unit found in the denominator or a unit that contains powers. The unit of density usually is in grams per cubic centimeter, but you might not want cubic centimeters in your final answer. So in breaking that down, I want to look at first denominators, then powers, and then put it together. You might get a density that is in liters or milliliters, and you might have to convert. So for this, we're going to follow the same pathway. It's just going to look a little different in the middle. First, we write our given value. And then in this case, looking at our conversion factor, you want your liters to cancel, but since this is based on algebra, liters is in the denominator. You're going to want to put liters in the numerator, actually. So we're working a little backwards. And then we want centiliters in the denominator, and we'll put that on the bottom. After that, we use our reference table. There's table C next to us. We follow the exact same pathway that we would before. And what we end up getting then would be 0.50 grams per centiliter. Does this make sense? Well, before we said when the unit gets bigger, the number gets smaller, but now since we're in the denominator, right, a liter is a larger volume than a centiliter, so with a smaller volume, since this grams per liter is a ratio, you should have a smaller mass. So that does make sense to me. When looking at units that have powers in them, it's not enough to just convert centimeters to millimeters, because if we were to do this, we would cancel out only one of these. Remember that square centimeters is centimeters times centimeters. So that doesn't work. What we have written here doesn't really work. So what we should be doing, and I'm going to be a little bit flexible because we've seen some problems like this already. I know that it is 10 millimeters per centimeter. We actually have to do this a second time because this would only cancel out one. We have to do it again. And that would cancel out the second centimeters in this process. Then doing your math across, you should get 1,100 square millimeters, because again, we've got millimeters times millimeters. That might seem a little odd when you've got 11 square centimeters, that 1,100 square millimeters would fit inside that. But do remember that, like, since it's in two dimensions, it's 10 times 10, and that's 100 per square centimeter. So putting this all together, we should be able to handle this pretty easily now. If you need to rewind to see it all together, see each step before. But again, we'll write our given quantity first, grams per cubic centimeter. And first we're going to multiply to get to meters. So we want meters on the bottom and centimeters on the top. But we're going to want to do this 3 times, once for each of the dimensions of centimeters. And so in each case, we're going to do this. I'm going to write 10 to the minus second on the bottom. And so that ends up being 10 to the 6th in terms of a difference. So that would be 2 million grams per cubic meter. Again, does this make sense? Well, a square centimeter is, kind of small, or cubic centimeter is kind of small. Cubic meter is sizably larger, and so if it's 2 grams per cubic centimeter, 2 million grams kind of logically makes sense. I hope this clarifies some of these harder unit conversions, and at least gives an example of how this is done that would result in a relatively quick and accurate conversion. Thanks for watching.